Hello and welcome to today's session. We're going to look at a magnetic fields question that is from paper 2. So when we deal with magnetic fields, quite a lot of the time we're dealing with particles moving in circular orbits. So when you see a question like that, you need to think about which equations are we going to equate. We're going to equate the force for a particle moving in a circular orbit, so F equals mv squared over r. And we're also going to use the relationship of the force acting on the charged particle, F equals BQV. So that's a force on the moving charge in a magnetic field. So most of the time when you see these questions, you'll think about these two things. So that's what we'll put down here. So F equals mv squared over r, and F equals BQV. We equate the two. These two equations are on your formula sheet. You just have to be able to manipulate them to get an expression. So sometimes you need to find the specific charge, so you can equate these two to get specific charge. Remember, specific charge is charge over mass. So equating those two, we can get that relationship out. Sometimes you might need to calculate the radius of orbit. Any variable that we need to find, we can do that by relating these two equations. So the first part of the question, you can see we've got this evacuated chamber. There's a proton that moves in a circular path. So as I said, we're going to think about these two equations. First part though says to define magnetic flux density. So if you recall how we defined magnetic flux density, we looked at the practical. The practical that we did was, I think it was required practical 10. So we measured the force on a current carrying wire. So for that, we looked at this equation for the force on a current carrying wire, required practical 10, F equals BIL. We use this for the definition of a Tesla. So the Tesla, or magnetic flux density, B, make B the subject, B is equal to F over IL. So remember, F is a force, I is a current, L is the length of the wire. So if we're defining magnetic flux density, it is where you've got a force of 1 Newton per meter for 1 amp, and the magnetic field is perpendicular to the wire. So it's got to be perpendicular to the wire. It's at right angles to the wire. So that's how we define the magnetic flux density. So if we write it out as well, so 1 Tesla when you've got a wire of current, carrying current of 1 amp placed at right angles to the field, and it's experiencing a force of 1 Newton per meter. So a force of 1 Newton per meter. And that's how we define it for 1 mark. Okay, the next bit. Write down an algebraic expression for the force on a proton in terms of the magnetic field at point P. So this is the evacuated tube. It's moving in a circular path. We know that there's a force towards the center F, and we can see that the velocity is going there. as well, so it's moving in that direction, and it's in a magnetic field. So an expression, as I said, what do we need to do? We need to think about the equations. So for that, for 1 mark, F equals BQV, because that's talking about the force on the proton in terms of the magnetic field at point P. Then the next bit talks about, so if I, let me number these, that's 1, 2, 3, 4. Next bit then, we need to find the value of flux density B needed to contain protons of speed 1.5 times 10 to 7 meters within a tube radius of 60 meters. Give a suitable unit for your answer. So this is the part where we need to equate the forces. So this is part 3. So as I said, with these circular motion type questions, we're going to equate the forces. Why do we need to equate the forces? Because it tells us about a radius, and if we look at F equals BQV, we don't have R in there, and we need to find B. So if we equate the two, we can equate the forces, we can get an expression for B on its own and work out what we need to find out. So let's do that. F equals mv squared over R. F equals BQV. We're going to equate the two. It's a proton, so we know the mass is 1.67 times 10 to the minus 27 kilograms. That's on your formula sheet. That's a mass. And we know the charge on the proton is 1.6 times 10 to the minus 19 coulombs. So equate the two. mv squared over R is equal to BQV. What can we do? We can cancel one of the V's. Then make B the subject, so B is equal to mv over RQ. Now what do we need to do? We need to substitute the values in. So putting the values in, mass of a proton 1.6 times 10 to the minus 27. Sorry, 1.67 actually. It's 1.67 using your formula sheet. 1.67. Then we have the velocity, so 1.5 times 10 to the 7. The radius is given to us, 60 meters. And the charge is 1.6 times 10 to the minus 19. So why is it 5 marks? 5 marks because we've got to equate the forces. We've got to rearrange the formula in terms of B, substitution into the equation. And then the other bit is to give a suitable unit for your answer. We also need to go to an appropriate number of significant figures as well. So that would be 2 significant figures. So what we need to do is just put that onto the calculator, give the unit, give it to an appropriate number of significant figures, and then we'll get the answer. So putting that into the calculator, we get the 2 significant figures. B is equal to 2.6 times 10 to the minus 3 Tesla. Okay, final bit then. State and explain what action must be taken to contain protons injected at twice the speed within the tube. This is part 4. And it's 2 marks and it's a explanation. So state and explain. So what can we do if we're thinking about this relationship? Looking at the relationship between this and so using what we've done here so far, we know that B is equal to mv over rq, and we want to contain these protons. So if we want to contain the protons, we want to keep them inside this chamber. So we're basically saying that we want to keep it inside this fixed chamber. So that means if we want to keep it in this fixed chamber, we're not moving at relativistic speeds. We're going to say that to keep it in the chamber, the mass is going to be constant, the radius is going to be constant, and the charge is going to be constant because we want to keep it in this fixed chamber. So in terms of proportionality, we're saying then that B is proportional to V. So again, just look at the question again. Look at the diagram. It's a fixed tube, and we want to contain it inside this tube. So these have to be constant. So if B is proportional to V, that means, because if those ones are constant, if we double the speed, if the speed is doubled, to contain the protons, we need to double the magnetic flux density. That is to keep the protons in the tube. Okay, so that's giving us 2 marks. Why? Because we've talked about it's a state and explain. So it's going to be doubled because of this relationship. So we've looked at the equation. So we've used what we've done in the previous part. As I said, with these types of questions, you're equating mv squared over r to bqv. We've got a fixed container. We want to keep these protons in there, and it tells us that the speed is doubled. So with these explanation questions, it's always introducing some proportionality. Speed is doubled. We're assuming that the mass is going to be constant because we're not moving at relativistic speeds. The radius has to be constant because it's in that fixed tube, and the charge of the particle is constant. That means that the magnetic flux density is directly proportional to the speed. So if we double the speed, we have to double the magnetic flux density. So that is typical question that we'd have for magnetic fields. It has the definition in the first part, the expressions that you usually have to do, and the explanation at the end. So these explanation questions, state and explain questions, or describe what's happening, you're usually looking back at this relationship. So when you've equated these two together, you shouldn't be surprised that the final question, if there's an explanation question, is going to link to what would happen if you increase B, or what would happen if you increase the speed, or something along those lines. And then to explain the answer, just introduce that proportionality. So what's being kept constant, and then a statement. And then that gets you the marks. So your task for today is to complete a magnetic fields question and submit it via Turnitin. If you've got any further questions, let me know. So drop me a message via Teams or email. Thanks for listening, and I'll see you on the next one.